Alright, so the goal of this video is just to get you started working in the ArcGIS Pro environment. So I'm starting here on the course page and then under the lab exercise content. So I'm just going to load in the data for the first lab, Intro to ArcGIS Pro, which we're not actually doing in the course. It's just like a background lab. So again, all the lab documents are here and then the associated data are over here. So I want to download the data, save that. And then that's just started download. I'm in Firefox, so it might look a little different if you're in a different browser. Okay, so then if I go into my downloads here, this is in my downloads folder, and I'm just going to extract that out. Again, it's a compressed folder. And this should provide a copy of all the data layers that we need for the lab and also the project file. Okay, so I'm going to go into exercise 1 project here, and that should open up the map documents. Now it's opening Pro. If it's licensed, it should open up without an issue. You might have an issue if there's a licensing problem. So just wait until the data layers load in here. Okay, so this just saying here I have a software update. ArcGIS Pro updates on a fairly regular basis. I'll deal with that later. You can see here that I'm logged in with my ArcGIS Online account. Again, you've been provided with one, so you can do the same. If you're in the lab, though, you can just use our license manager. It doesn't really matter for the class. All right, I'm going to close some of these panes because we don't need those yet, just to simplify this space. Okay, so here I have a project file. This project file specifically has some layers in it associated with West Virginia. So first off, you should know the difference between a project file versus data layers or data files. So a project file isn't a data, it just represents like a workspace where you can generate maps, layouts, toolboxes, tools, scripts, whatever. So this map project is called Exercise 1. If we go back to the folder here, you can see that it's a .aprx file. Again, those are the project files for ArcGIS Pro. See, project file. All right, so let's close that. Now, within a document, you can have links to data layers. Note that these aren't really stored as the part of the project, but the project just references them. So if you just sent someone a project file, they're not going to have access to all the data layers. They need to actually use it. Okay, so these are some of those data layers. Let's expand this a little bit. So we have a point layer, a line layer, some polygons, and then some raster grids. Note there's also a default Esri base map. This is the topographic base map, and you can turn that on and off if you want. It's just there basically for reference. Okay, so let's start off by actually adding some new data to the map. So one thing that is potentially confusing is where to go to move into a different project versus where to go to move into a map. So to do that, you go, to open a new project, you go to the project tab, and then you can either save the current one, save a copy of it, or open a different project. But we don't want to do that. We just want to add a data layer into this project. So there's a different method for that. So to add a data layer in, you go to the Add Data button, and then that'll open up links to data. All right, so as a few examples here, I have access to some of my local drives, so my desktop, my documents folder, my downloads, and then some of my hard drives, and also here's a server connection. And then this area under portal, those are like web data that you're linked to. So my content, for example, is my data that's in my ArcGIS Online account, and I should be able to access that if I'm logged into that account. And groups and portals are other data layers that are associated with your organization or groups that you're in your organization. The Living Atlas are data layers provided by Esri. So if we go over here, we can search for some data. So I'm just going to type in Landsat, and there's some data associated with Landsat. Up here in the top part, we have some like shortcuts. So this links to databases that you have links to that will automatically link to the default database, which is this Exercise 1 database. And then you can also have links to folders. So if I go into this exercise 1 database, those are some data layers. Note most of these are already pulled in and symbolized. The only one that isn't is this springs layer, so I'm going to add that. So click on it, okay, that adds in that layer. So now we have all these points in the state that represent springs, or where there's an outflow of water from the ground. So that's that. So generally when you pull in a layer, it's not going to look the way that you want it to, because it just pulls some like random symbology. So we might want to change the symbol for this, and there's different ways to change symbols. So what I'm going to do now is just show you how to change symbology for different types of layers. So we're going to start off with points. So for this springs layer, if we click on the symbol, we can it opens up a pane where we can change the symbol. Here's a bunch of default ones. You can also search for stuff. I don't know if there are any like spring symbols available. Doesn't look like it. Let's try water. So there's some water related things that really doesn't make sense here. So instead of using one of the galleries, we're just going to go to properties, and we're just going to change the symbol. So here we're going to change the color. I'm just going to make it a blue color, and the size. So it's pretty small now. I'm going to step it up to 12. That's probably too big, but so there we've just changed the symbology for that object. If you wanted to change the symbology for airports, you could do the same. So I'm just going to double click on that. Go to gallery. We have one airport already, or an airport symbology already used, but we could pick something else. Basically the same thing, just different sizes. So that's just the middle size, made it a little smaller. So that's it for points. For lines, similar. So here's the interstates. So for example, we want to change it to this highway. That changes the symbol there. Just picking some different symbols. I'll just leave it at that for now. If we want to go to properties, then instead of just picking something from the gallery, we can go in here and change the color, the line width, just change how it looks. All right, so for vector objects, so let's look at I'm going to turn some stuff off since we don't need it right now. So for some polygon objects, like the county boundaries, you can change both the color and the outline used. So just to show you a different way to do it, instead of double clicking on the symbol there, you can right click and then go to Symbology, and it will open that up, and then you have some symbol options here. So it's different. It's common in Pro to be able to get to the same screens using different methods. Okay, so I'm going to just mess with the color. I'm going to make it like a lighter tan, and I'm going to make the lines a little lighter, and then I'm going to step up the size a bit of the outline. So there we have a slightly different symbology. Again, we could also pick something from the list of symbols here if we wanted. That one's not great, it doesn't have borders. So there's lots of symbology options. Okay, another thing you might want to do is make a layer like semi-transparent so you can see through it to see other layers or the base map or whatever. Okay, so accomplish that, you can go to Appearance, and then this is the transparency. So if you put it all the way up to 100, it disappears, and then there's different levels of transparency in between. The default is that it's completely opaque or not transparent at all. The swipe tool is used to swipe between two layers to see like overlap. That's another useful tool for just visualizing data. All right, so these are all vector layers, point lines, and polygons. Then we have two other layers here that are raster grids. So this is a raster grid of land cover where each cell or a pixel holds a number, which is a stand-in for a category. So for example, all these red colors represent different levels of development. The blue represents water, the green represents forest. So here I have a unique symbology where each unique code is assigned to a category, and I've assigned a color to that category, which kind of makes sense for it. For example, forest is green. If you wanted to go in here and change something, you could. So if I just click on the symbol, go in here, and we can change it. I just accidentally changed it to a blue color there. So you can, again, pick different color ramps, change different symbols. So I'm just going to change this back to blue. Say, for example, we wanted, let's see, we could make all these like shades of black instead of shades of red. So we'll just scale up from very light to darker. So again, it's changing the symbology. So generally when you have something categorical, you pick colors that aren't in like a sequence or an order based on hue, just colors to represent different categories that are qualitative. All right, so that's that. And then underneath of it, we have this elevation layer, which is elevation in meters. So we've got a color ramp already assigned to that. So if we click over here, we can see that this is using a different type of symbology. So instead of unique values, we have a stretch, so it's stretching from the lowest to the highest value. So we could go in here and pick a different color ramp. The one that we have is probably fine. Let me use this one. So that's a little bit different color ramp for that display. Another thing you can do is instead of just stretching through all the colors, you can bend them. So there's different methods for that. So in this case, instead of using stretch, we'd use classify. And we had to pick a value to use, which we use the value field, which is the elevation, and then we can't normalize it because it's something normalized by, and we pick a method. We're going to talk about this stuff later on in the class, and then we can pick a ramp to apply to that. Let's see, use this again. So again, the idea here is that instead of it being a continuous stretch, it takes ranges of values and assigns a color to that range of values. And then at the bottom here we have one more grid. This is a hillshade, which is a topographic representation. We probably really don't need to do anything with that at this point. Okay, so most data layers are going to have not just the spatial information, but they can also have tabulated or aspatial or table information. So it would be nice if we could also access that information. And we can. So to access that information, if you click on a layer, I'm just going to click on this limestone layer here, we can do attribute table, and that'll open up an attribute table with information about each of those features. Just turn it on so we can see it. There should be a one-to-one relationship between the features in the map and features or rows in the table. So for example, if I pick this object, it should have just highlighted one map feature, so this one here. So this map feature corresponds to this record in the table. And then each row is an attribute or some information about those features. All right, if you want to export out just the aspatial information, there's a couple ways you can do that. You can do, on the data tab, you can do export table, and that'll by default just export the table without the geometric information. So you could save it as like a text file or like a CSV file or database file or something. If you do export features, it's going to export the geographic information and the attribute table. And then by default, it will only export what is currently selected. So I only have this one object selected, so if I ran this tool, then I'm just going to get back that one feature. So you can see there. If you wanted to have all the features, like make a copy of it, then you could clear the selection or select everything and run it, and then that'll make a copy with all the features in it. So here we have just a copy of the data. All right, so another common thing that you're going to do with data layers is just query them to find features that meet certain criteria. So for example, if we go in here to counties, we could try to find counties again that meet certain criteria, and that can be done with a selection. So I'm going to use select by attribute because I'm going to use the attribute information as opposed to the spatial information. And I'm going to add, well, we got to pick an object first. We'll grab counties, and then we'll do add clause. So let's find all the counties. This is the population that are greater than, let's just do 40,000. And I'm making this up on the spot, so I don't know what that's going to yield exactly. So this should just select all the counties that have at least 40,000 people in them. In 2000 anyway. All right, I'm going to close this table. Well, actually, we'll leave that open. Let's open up the table for that layer. All right, so if I click on this little show selected records, those are the only ones that were selected. There's 14 of them. So 14 out of the 55 counties had a population greater than 40,000 in the year 2000. And again, they're highlighted there in that like cyan color, and in the table and in the map. So let's say you wanted to make a copy of those layers. Well, you could do the same thing. You go to Data, Export Features, or you could just export the table. You can also go over to the layer and the Contents pane and do Data, Export Features there. It's the same thing. And then you can export those out. So now we just have a copy of the data layers that have the more populated counties in them. Okay, so that's a common technique that we use in GIS, coring information based on their attributes. Let's just do another one real quick. So let's look at the springs. So I'm going to open up the table here so we can see the attributes. So it has this average flow. So let's find all the springs that have an average flow greater than, how about 2,000? So again, we can go back to the map. We can do a select by attribute. Now we want to do springs. We'll add a clause. We'll set it equal to average flow. We want it to be greater than 2,000. And then that should select the points or springs that meet that criteria. So it's just those ones. You can also add multiple clauses. So we're going to say and we want it to be in, let's see, we'll pick topographic position is equal to, let's see here, we'll do valley. See if anything pops up. 12. So in this example, out of the 249 springs that are mapped in the data set, 12 of them have an average flow greater than 2,000. I'm actually not sure what the units are there. And they also occur in valley topographic position. And again, you can make a copy of those and export them out. A couple other notes before we call it quits with this. Let's say you wanted to copy a raster grid. It's basically the same process. So you would go to the grid you want to copy, right-click, Data, Export Raster, and then it opens up this Export Raster panel where you can export that data out. You also might be interested in looking at the characteristics of a data layer. So, for example, if we wanted to see characteristics of this elevation layer, we could go to Properties. And then under the Source tab, it'll tell you some information about it. So it's a file geodatabase raster, which means it's a raster stored in a file geodatabase. This is its current location on my local machine. That's the name of the data set or the data layer that's being referenced, and the units are in meters. Under raster information, it tells you the number of rows and columns of cells, the number of bands, it's just a single band that holds elevation measurement, the resolution, so 30 by 30 meters. This is the size it would be if there was no compression, which there generally is some, so it's probably less than 345 megabytes. Again, that's the format. It's a geodatabase raster. It's a 16-bit grid, which means it can hold 2 to the 16th number of unique values. The pixel type is short, so in this case it can't hold decimal places, it has to be rounded off. And then under statistics, it'll tell you some information about the cells. So the lowest value is 0, or elevation of 0 feet above sea level. The highest is 1490. That would be, again, meters above sea level. The mean is 510, and then that's the standard deviation. And then lastly, this bracket tells you some information about the spatial reference. So this is referenced to the projected coordinate system, NAD 83, UTM zone 17 north. So it's referenced to the 17 north UTM zone. That's a transverse Mercator projection. That's what the TM of UTM means. These are some unique codes for that you can use to look it up, that specific projection. The units are in meters. That's the unit assigned to the false easting. So the center meridian is assigned a value of 500,000 meters, and then the false northing is 0, or the equator is assigned a value of 0. This is where the false easting is. Oh, sorry, here we go. So it's negative 81, which is basically 81 degrees west longitude. And then this is the origin for the latitude, which is 0, so it's the equator. And this is the information about the geographic coordinate system. So it's referenced against this coordinate system. So it gives you some information about the geographic datum. So this is like NAD 83, right? North American datum of 1983. and then some mathematical properties of it. Okay, so we looked at how you bring data layers in, how you change the symbology, how you look at the attributes and query the attributes, and then also we looked at this getting information about the data layer itself. Let's say you made changes to this and you want to save it before you close. You can do to project and then save, and that'll save any changes. It should ask you also, if you just hit close, it should ask you if you want to save beforehand. If we did save as, I can make a copy of this. Okay, and then lastly, one other thing that you're going to work with in here is layouts. So you can kind of work in two spaces. You can work in the map space, or you can work in the layout space, like on a piece of paper or a layout. So to create a new layout, you go to Insert, and underneath here we have a couple different options. We can create multiple maps to store in here, and then map layouts. You can also have 3D scenes, local and global, create new base maps. So what we're going to do is create a new layout. So I'm going to go to New Layout. You can pick a paper size, and if you want, you can change this later. I'm just going to use 8.5 by 11 landscape. So this creates a new map space. And then I'm going to add my map to it. So I go up here to Map Frame. This is under the Insert tab. And I grab that map object, and I drop it in there. And then I can add some other things. So I could add like a north arrow. And I could produce like a scale bar. It could add a legend, although in this case there's really nothing to show. Could also add some text. So again, this is like layout space, whereas this is map space. When you're working in this environment, it gets kind of confusing because you have kind of two options, or two spaces you're working in, map and layout. So if you want to move the map around in the layout, you have to right click on it, hit activate, and that allows you to use the map within the layout. So like zoom in, zoom out, change the position, and then exit to go back to the layout space. We're not going to talk about all the nuts and bolts of making a map layout yet, but if you wanted to export it, you just go up here to Share, and then Layout, and then that'll allow you to export to a graphics file, so like a PDF or a TIFF or a JPEG or a PNG. Alright, I'm just going to go back to the map for a second. One other thing before we end it is if you go to the map tab, this is all the information for navigating around a map. So you're going to use this a good bit. So under Explore here, if you click on that tool, you can navigate around. So pan, north, south, east, west. You can also use the scroller on the mouse to zoom in and zoom out. What these buttons do is allow you to zoom to certain extents. So this would fit all the data to the current, this allows you to zoom out at a fixed rate. This zooms in at a fixed rate. I don't use those too often. This would zoom to the extent of the mapper data. This is actually zooming to the full extent of the projection there. And then this zooms to a prior extent. So you can kind of go backwards and forwards through your extents. Bookmarks allow you to store a location. So you can have a certain zoom and extent you could go back to. So if we really liked this for some reason, we could do bookmark, new bookmark, and we'll just give it a name. We'll call it West Virginia 1. Okay, and you could put a description there. And now if I zoom out, I could go to the bookmarks and click on this, and it'll take me back to that extent. So it's like saving a location or a view location. Okay, so that's just a quick introduction. So what you're going to do in lab in the first week is play around with datums and projections, but you'll be doing some of this stuff because you'll be working in the map space. So I will see you guys in a week.